This is section 8.6, and basically 8.6 is the biggest factoring section that we'll have because it requires us to take something and determine which factoring method we're going to use. They're not going to tell us, hey, you should use factor by grouping for this. They'll give us an expression and they'll just say factor completely. So we'll have to kind of determine which method we're going to use, and then also know that sometimes we'll use more than one method. So for instance, you can see on this chart here, which is something I can email out if you want it, just let me know. You're always looking for a GCF first. So you look for a greatest common factor. You always want to take that out first because it can make the rest of your expression easier to factor. So always looking for a greatest common factor no matter how many terms you have. After that, you want to look at how many total terms are left to be factored. If you have 2 terms, you can check to see if there's a difference of 2 squares. If you have 3 terms, a trinomial, we can kind of guess and check or take the direct route and see if that's factorable. And if there are 4 terms, we're going to look into grouping. And as I have indicated, especially under the 4-term section, there may be some further factoring you have to do even after you group. So we'll see what that looks like. And sometimes all you can do is take out a greatest common factor no matter how many terms you have. So you might only be able to divide out one thing and then that's it. It's factored. And sometimes you'll get an expression that can't be factored at all. So there are a bunch of different situations we can run into, but I'll try to go over the main ones that you'll run into here. And this is all with quadratics. Now remember that quadratics means we have an x squared term. So other than when we run into the difference of 2 squares. So that can be one that doesn't necessarily use a quadratic, but I'll show you what I'm talking about here. So starting off basic, this particular trinomial, we have 3 terms. Remember, always check for a GCF first. They can all be divided by 2, and then I just check to see what I'm left with. We divide everything by 2, and here we are. So now 2 will be a part of my answer, and what I'm going to want to do is factor that piece right there. So if it's factorable, it's going to come down to 2 sets of parentheses, and don't forget we will have a 2 as a part of our answer because that is also a factor. Since there is no number in front of our x squared term, there's just a 1, that makes this a lot easier because then we can just play the game of 2 numbers to multiply to 4 but add to -5. So I know they both have to be negative because 2 negatives multiplied gives me a positive, and then I need those 2 negatives to add to a -5. So I know I'm looking at 4 and 1. Okay, so this would be our final factored answer. If that's not clear to you, this is stuff we talked about back in 8.3 and 8.4. Okay, so I'm not going to dive into that too much, but that is the factorization of that expression. This one also has some GCF that we can factor out, and it's a little bit different than the first one because not only are they all divisible by 3, I can also take an x out of all of them because they all have at least one x. So that's going to take an x away from each of them on the inside, and we're also dividing them by 3. So here I'm left with 2x squared plus 1x, or just x, minus 6. And what we'll want to do is factor this piece now. So we know that 3x is a part of our answer, and we're going to get something that looks like this. Okay. Now you can either guess and check with this trinomial, or you can take the direct route. And what I'll do is I'll just review the direct route. So 2 times -6 is -12. I need 2 factors of -12 that add to 1, which would be 4 and -3. So we're going to rewrite 1 as 1x as 4x minus 3x, and then just drop down 2x squared and minus 6. Okay, and then we factor by grouping. So this is the direct route. Again, you can always go guess and check, which would be fine. So out of the first one, I can take a 2x out, and I'm left with x plus 2. And out of the second one, I can divide out a -3, and we're left with x plus 2. So we do have a common factor of x plus 2. That could go here. It could also go in the second one. It doesn't matter. And then we have 2x minus 3 left over. and this would be our factored answer. Okay? So there we had to do a GCF and then factor the trinomial. All right, 2 more examples. 4 terms here. First, check for a GCF. Unfortunately, we can't factor any greatest common factor out because not all numbers have something that will divide them evenly. So 4 terms, we're looking to go factor by grouping. And we'll see where we're at. So between the 4 and the 3, I can't divide out any numbers, but I can take out x squared because they both have at least 2 x's. So I'd be left with 4x plus 3. And then out of the second group, I can divide out a negative 4. And I'd be left with 4x plus 3. So remember, taking out a negative will change the signs on the inside of the parentheses. And that's just because if I redistribute the negative, they'll turn back negative. So stuff that we've already gone over. So here we've got 4x minus 3. Those match, so that's one of my factors. Or sorry, plus 3. And then we have x squared minus 4 left over. And here's where we're not quite done yet. So this is one thing that we're going to have to take note of. We have a difference of 2 squares right here, which we know, as we kind of remember, if there's no middle term, there's a 0x there. So we're looking for 2 numbers that multiply to negative 4 but add to 0, and those are going to be opposites. So x plus 2 and x minus 2, because negative 2x and positive 2x add to 0, but 2 times negative 2 gives me the negative 4. So that's the shortcut for the difference of 2 squares. So anytime you have 2 squares being subtracted, you can just take the roots of the first and the second number and then give them opposite signs, and now we are factored. Okay. The last example will also have that portion involved with it. Out of these 2, I can divide out a 4x, and then I'm going to be left with x to the 6th minus 4. And it doesn't look like it, but we actually have a difference of 2 squares here again, because x to the 6th can break down into x to the 3rd times x to the 3rd. Remember, we add those exponents if they have the same base. And then 4 is a perfect square with 2 and 2, and one of them is going to be negative. So really what we have here, and you can check this, negative 2x to the 3rd plus 2x to the 3rd cancels, so there's no middle left. That's why it's a difference of 2 squares. So our final answer here is 4x, and then x to the 3rd minus 2 times x to the 3rd plus 2. And again, you could reorder these. It could have been 4x times x squared, x to the 3rd plus 2 times x to the 3rd minus 2, doesn't matter. So anyway, there are a lot of different routes and different examples I could show you, but these are good ones to give you a good base for the things to look out for. The biggest thing to watch out for would probably be the difference of 2 squares, to know that that can be factored one step further. All right, that's all I got.